Today we're going to talk about Learning Objective 2.4 frequency distributions. A frequency distribution is a grouping of data into mutually exclusive classes showing the number of observations in each class. So I want to focus on this word distribution. We are looking at how the data is spread out. We are trying to gather information on the distribution or the spread of the data. Another thing I want to point out is this term mutually exclusive. Mutually exclusive means that you can't have crossover in your categories. So example, an employee couldn't walk 2 miles and also walk 6 miles in the same day. So let's take a look at this example and then we will analyze the frequency distribution. Suppose a researcher wanted to do a study on the number of miles employees in a large warehouse walked during their shifts each day. The table at right shows the raw data in its original form. Raw data is exactly what it sounds like. It's like raw food. It's unprepared, unorganized, and that's what we're going to be doing by creating this frequency distribution. So let's go ahead and look at this table over here. We are going to try and find some useful information. So first I'm going to try to find the smallest datum. Datum is the singular for data. So I'm going to look for the lowest, and 2 is our minimum. And all of this information is going to be useful when we actually get started in creating a frequency distribution. And then our highest, I can see here we have 2. Our highest is 11, so that would be our max. If we take a look over here, we can easily see the total number of observations that we have. We can look here, and we've got 6 columns and 4 rows, so our number of observations is 24. Again, that's going to be a valuable piece of information when we start putting this together. Now if we look over here, this is the actual frequency distribution. So this over here is the number of miles. It's our class limits, and we have, you can see, 1, 2, 3, 4, 5. We have 5 classes. Something that's interesting about finding our classes is we could have a different number of classes. This is something that you have to learn how to decide on the number of classes that's appropriate for each different frequency distribution that we come across. What we're looking for is we want to make sure that we have enough classes that we can see the distribution of data easily. So from here, we'll take a look at these class limits. And this 2 to 3, this is our class width or class interval. It's how far it spans from the lower value to the upper value. So in this case, the 2, that's our lower class limit, and the 3 is our upper class limit. So in different situations, these could be different values. It could be from 200 to 300, 2,000 to 3,000, and so on and so forth. But in this instance, we have 2 data values. We have 2 and 3. And then you'll notice here, remember these are mutually exclusive, so there's no overlap. If we look at the next one, it's 4 and 5. All of the classes have the same width, none overlap, and they're all continuous, so there are no gaps. So I couldn't do 2 to 3, 6 to 7, 8 to 9, 10 to 11. Okay, there's no gaps, it's continuous. And we also want to make sure that these class limits cover the whole data range. We want to make sure we're covering all the way from the minimum value to the maximum value. So the next is the middle, and you won't always have this tally section. I like it because it helps me stay organized when I am analyzing the data. So this tally just goes through and you count and you tally how many you have of each observation. And then this far right column here, it's our frequency. So in this scenario, it's our number of employees. And all I simply did was I added up my tally marks to get my frequency. So we have 3 employees that walk between 2 and 3 miles. We have 10 that are from 4 and 5 miles. We have 6 that do 6 or 7 miles. And then always at the bottom, it's a good idea to total your frequency. This is just another way of self-checking and verifying that you have accounted for every piece of data. So I added all these up, I got 24, and my number of observations is 24, so I know that I have collected every piece of data into my frequency distribution. So in summary, I just want you to know that a frequency distribution is a really good way of showing how often we have certain events occur. So we can quickly look at this and see that the majority of the employees at this warehouse walk 4 to 5 miles a day, and the next largest is 6 to 7. So, the majority of the employees here walk this many number of miles. So in the next video, I'm going to show you how to actually construct this frequency distribution and some of the simple calculations that are needed to make that happen.